Okay, so starting the second video, we're going to look at number 3 on the chapter review. So a couple ways to do this. We could do this one all algebraically, or we could do a combination of the two, either graphing and algebra. So if I can fit the points on the graph, I typically try to. Negative 4, 3 is A, so graph and label. 1, 2, 3. So then we get D at 0, 6. 6, that's R. And then K is at 8, negative 9. Okay, so what we're looking at is we know that they're not the same line, okay? Because you're looking at R to K, you're looking at A to D, all right? So that helps us a little bit. We know they're not going to be parallel, okay? Now it's a matter of, are they perpendicular? All right, one way to calculate the slope using the graph is simply like this, getting the rise and run, right? Where slope, okay, slope is rise over run, or you can use the algebra, y minus, I usually do y1 minus y2, but that's just me. Okay, you can do it either way. So let's start with AD. We try to label really well and show our work really precisely. So do the best you can there. So we have 4, 1, 2, 3. So our rise is 3, our run is 4 for AD, and it is moving up as we move left to right. So that's going to be a positive slope. Okay, R to K. All right, we know it's going to be a negative slope because it's going, as we move left to right, that one's going down. So let's take a look here. We got 1, 2, 3 is the rise. 1, 2, 3, 4 is the run. Okay, so it's a negative 3/4. That is not perpendicular. The reason is that this would need to be negative 4/3. We'd have to flip the fraction too. So they try to trick a little bit on this one. It's not perpendicular. Okay, we needed the slopes to be negative reciprocals for perpendicular, so we have neither. All right. Okay, so let's read this carefully. Bisecting a what? Pause when you do these kinds of questions. If you're bisecting a segment, we should get 2 equal segments. Okay, HE is what is being bisected. HE is what is being bisected. All right, so GI bisects H to E. Those are the same. That we know for sure. So we should get G to H is congruent to G to E. Now let's find one of the choices that's similar. You know what? That's going to be close enough, right? They just said HG equals GE. Okay, so that's going to be good enough. Switching the letters around is fine. We found the one we're looking for. Good. Go.
Hi, it's me, Madison. Students, good luck on your test.
All right, thanks. She was dying to say something there on the last video, so all right, now we'll get going again. So now on to some equation of lines. Now we know lines, remember our definition for lines? You know, the collection of all points on a straight path, right? So here's what happens now when we move to a more advanced geometry course. Now we take equations from algebra, and now we apply it to defining these points. So our equation is going to define all the points on the graph of the line algebraically as well. Okay, not just drawing it in space. We actually have a graph to use. So what I would do probably on this is go. You know, it's designed. This problem is designed to use this format. Now we learn this point slope format. where your point is x1, y1, and your slope obviously is m. Okay? So that's the design of this question. That's really what we're looking for. So let's try to go through that the way it's designed. Okay? The original line, the only thing we need from that original line, all right, all we need from that is it's the slope of it. Okay? So for the original line, original line has a slope of whatever you multiply x by. Yeah, we know it's not in this format, y equals mx plus b. You could add the 3 over, but that's not going to affect the slope. The slope is whatever when y is by itself, okay, whatever we're going to multiply x by. Okay, so if we did add that over, it would now be in the correct form. Okay, so that's our slope, -2 of the original line. Now what I'm going to write is this symbol perpendicular, the upside down T. A perpendicular line will need a slope that is positive 1/2. Okay, it's -2 over 1. We got to not only give the reciprocal, but the negative reciprocal. So a negative times a negative is a positive, and then flip this fraction. So our slope needs to be 1/2. Now what I can really do right now is go through all of these. Okay, I know it's not C or A. Those are going to probably be parallel lines. Okay, now we wanted perpendicular though. Okay, so now what we have to do is we have to apply our point. So I'll just write this again. Basically, I need to know -9, 2, that's my x1 and y1. So, really quickly, it's going to be y minus 2, and equals our 1/2. We wanted to use that slope, and it's x minus -9. So we should get y minus 2 equals 1/2 x plus 9. Now, of course, there's a way to do this using the graph and using y equals mx plus b form. But, this is the design of the problem. This is how we should have done it. And hopefully we can find that. Yep, it's going to be b. Okay. All right, let's keep going. So this one's more intended to be, the slope intercept. When I'm not sure if it'll fit on the graph. Let's try it. And so I'll go grab a graph. Okay, so we'll plot the point 8, -8. Alright, so there it is, 8, -8. And we want to have a line that's parallel to that line. Wow. Okay, it's probably not going to work using the graph, okay, because I'm seeing it right now. The original line has a slope that is 8 over 1. A parallel line, that's the symbol for parallel right there. Double vertical line, okay? So a parallel line must have the same slope. Now there's no way I'm going to go up 8 over 1. Okay, I could keep doing that. Down 8, left 1. I mean, it's going to take us a long time to run into the y-axis. So this is how they force it on us to learn this format. Okay, so again, here it is. Memorize that point slope format. All right, our coordinate that we have to pass through is 8, -8. That's x1, y1. So we're going to say y minus -8 equals, now the m is going to be replaced with the same slope this time, and x minus 8. What we have to now do is some algebra. We'll have to distribute that 8, right? So it's 8x minus 64, and then subtract 8 from both sides. Now that makes some sense that we know it's going to be really low, right? We'd have to go down 8, left 1, down 8, left 1 continuously. We're definitely not going to run into positive 72. This is the wrong slope. That's the wrong slope. That's the right one, and that's what we're looking for. Okay, so that'll be the end of the second video for the chapter review. Next one coming soon.